Also, as we move through the learning on our course, we'll also see how the earthing arrangement, in this case TNCS, has a maximum external earth fault loop impedance of 0.35 of an ohm. We've identified at the origin of the installation the earthing arrangement is TNCS. We're now going to carry out the external earth fault loop impedance to confirm our external earth fault loop impedance is no greater than the maximum allowed for this installation, which is 0.35 of an ohm. In order to measure the external earth fault loop impedance in this installation, I'm going to need to take off the cover of the distribution board. I have no separate MET where I could disconnect my 16mm earthing conductor, so it must be disconnected from within the consumer unit and where it is terminated in the main earth bar. In order to do this, I'm going to need to isolate the consumer unit at the main switch, the linked main switch or double pole switch. I'm going to need to isolate that, turning off both line and neutral. Before doing so, it would be advisable to turn off individual, in this case circuit breakers, to reduce the amount of load that I would be switching off. It is advisable to tell the customer before turning off the electricity, not just for inconvenience sake, but if they have sensitive electronic equipment that's in, on and being used, it would not be advisable just to turn the power off to those type of equipment. So it's best they power down those items before you turn off the electricity within the distribution board itself. I'll turn off each circuit breaker in turn before I turn off the main switch itself. I can now turn off the main switch and then I can remove the cover. I still need to be careful because the top of the double pole switch will still be live. The rest of the installation will be isolated once the main switch has been turned off. So I'm now going to remove the distribution board cover. Before doing so, just going to move this out of the way and take off the cover. Exposing the conductors underneath. So distribution board cover is off, and we can see that even the live parts on the top of the double pole switch is shrouded from contact, and the bottom of the double pole switch going through is all been isolated. Therefore I can disconnect my 16mm earthing conductor in order to perform the test. With the 16mm earthing conductor removed from the main earth terminal, the parallel earth paths created by things such as gas, water and oil have been removed, giving you a true external earth fault loop impedance of the installation. In order to carry out this test, I need to set my MFT to the appropriate range. In this case, I need to go into the green section here, which is L for line and protective earth. And I need to move it on this side into the green zone against Z, Z for impedance. We're measuring the external earth fault loop impedance, and Z is representing impedance. I've set my instrument on to 2 lead high for this test. I've got the left hand one on line protective earth and my right hand one on impedance. So I'm going to carry out the test now to see what reading I get. I'm going to probe onto the least dangerous conductor first, which in this case is the earthing conductor, and then onto the line to do the test. And when I come back off, I'll pull off the line conductor first and then off the earthing conductor second. My probes themselves conform to GS38 with no greater than 4mm exposure tip. This is considerably less than 4. So I'm going to probe onto the earthing conductor first, and then I'm going to probe onto the line conductor. And I've got a reading of 0.25 of an ohm. I'm going to pull off the line conductor and I'm going to pull off the earthing conductor. There we go. The external earth fault loop impedance has been measured. It's less than the 0.35 ohm of the maximum, being 0.25. Therefore, we've proved the external earth fault loop impedance meets the requirements. With the earthing conductor reconnected and the distribution board cover replaced, we can now turn on the main switch and individual circuit breakers.